Hello, everybody. Today we're going to talk about similar polygons. Okay, so two or more polygons are similar if they're the same shape, but not necessarily the same size. That means that all the angles which determine the shape are equal, but the sides are not equal, but they are proportional. They're the same ratios all the time. Okay, so here we have two triangles. The statement here is triangle ABC is similar to triangle DEF. This is a similar to sign. Okay. Here we have QRSTUV. It's a hexagon, is similar to HIJKLM. Now, notice that A and D are the same corners of the triangles. They're the equal angles. B and E, they're both the right angles here, right? They're in the same position. They both come second. C and F go together, they both come third. So you can get a lot of information out of this the similarity statement right here. You know, if I just have this, I know that angle A and angle D are equal. Angle B and angle E are equal. C and F are equal. I also know that side AB and side DE are proportional. Okay, they have the same ratio as BC and EF and AC and DF. Okay, so let's just go back and review proportions here really quickly. You should know how to do this, so I'm going to let you pause the video here and do these, and then jump back on and see how you did. Okay, so remember when we solve a proportion, you always multiply the two diagonal numbers together and divide by the other one. So x equals 8 times 12 divided by 3, which is, 96 divided by 3, which is 32. Okay. Next up over here, y is going to equal 10.5 times 4 divided by 7. Okay, so 10.5 times 4, that's what, 42. Okay, divided by 7, so y is 6. So hopefully you got 6 for y. Okay, down here, z is going to equal 2 times 9 divided by 5, which is 18/5. Okay, we'll probably just leave it like that. You could write it as 3 3/5 if you like, or 3.6. Any one of those will do. And then finally, we've got w is going to be 32 times 50 divided by 12. So what's 32 times 50? 1600 divided by 12 comes out to 133 1/3. Okay, so hopefully you got all those correct. All right, moving right along. So, are these two triangles similar? Well, the first thing you need to do is you need to check all the angles. That's the quickest, easiest thing to do. And if all the angles are not equal, then these things are not going to be similar. So I've got, those are good right there. Okay. Now what I need to do is figure out what this angle is. So I'm just going to take 180 minus 83 minus 55. And that comes out to be 42. Now that also means that if I was to do this, this would come out to be 55. All the angles are equal. So yes, these two triangles, well, they should be similar. Now I need to check to make sure the sides are proportional. Now technically, if you have the three angles of one triangle equal to the three angles of another triangle, it's automatically going to be similar. But that's true for triangles. That's not necessarily true for everything else. Okay, so let's check here. 12 is to 4. Is 21 is to 7. and that would be 24 is to 8. All of those reduce to 3 over 1. So yes, these are similar. All the sides were proportional. All the angles were equal. Okay. So we have SMAL is similar to BIGE. Find X and Y. Okay, so they're telling you these are similar. So right away, I got an angle here. It goes with angle I goes with angle M. So I know they have to be equal. So this has to be 38 degrees right there. So that was easy. We'll get that off the table right away. Now, the other one's the sides. I got to find that they're proportional. So what I need to do is find two sides that go together. So 18 and 24, those go together. I'm going to make a proportion from them. That has to equal, now I've got my small as to my large, so my small goes on top here, and my large one goes on the bottom. There's my proportion. You know what, I can reduce this. 6 will go in there 3 times and in there 4 times. So I'm going to reduce this to 3/4 equals 21 over x. Okay, that's a little easier to do. Then x is going to be 4 times 21 divided by 3. So 4 times 21 divided by 3 is 28. And my unit's in feet, so it's 28 feet. And I always like to write these things on my picture because a lot of times with these type of problems, I have multiple things to do. And knowing this might give me something else in the picture. It doesn't in this case, but that does often happen. So make sure you write on the picture. Okay. AA theorem stands for angle-angle. If two angles of one triangle are congruent to two angles of a second triangle, then the two triangles must be similar. Okay, the reason for that is because if these two angles are equal to those two angles, guess what? These two angles have to be the same. Okay, so every triangle is 180 degrees. So if I take away 65 and I take away 38, that leaves 77 for this one and 77 for this one. So if I have two angles equal, I automatically have three angles equal. And if all the angles are equal, then the two triangles must be similar. So we get my congruent statement here. Triangle QRS is similar to triangle TUV. Side-side-side similarity. Okay, if in two triangles, the three sides of one triangle are proportional to the three sides of the second triangle, then the two triangles must be similar. Okay, so very much like triangle congruence. Remember triangle congruence, side-side-side said if the three sides of one triangle are congruent to three sides of the other triangle, then the two triangles are congruent. Well, this one says if they are the same proportion, then they're similar. So right away, I'm going to check to see 10 is going to go with the 15, so we'll go do this. 10 over 15, is that equal to 12 over 18? And then the other one's also 12 over 18. So normally I would do this, but I don't really need to do that. Okay, I'm going to reduce these. All of these are equal to 2/3. Okay, 5 goes in there twice, 5 goes in there 3 times, 5 goes in there twice, or 6 goes in there twice, 6 goes in there 3 times. So they're 2/3. So that would imply yes, they are similar. And I would write my similarity statement right there. Side angle side similarity. If two sides of one triangle are proportional to two sides of a second triangle, and the included angles of the two triangles are congruent, then the two triangles are similar. Okay, so remember, an included angle is an angle between two sides. So this 15 degrees is included between 10 and 18 because it's between those two sides right there. Angle A would be included between 10 and side AC. Okay, and angle C would be included between 18 and AC. So I look here, I've got a side, angle, side situation, side, angle, side. The angles are equal, so that's good. So I just got to check to see, are the sides proportional? Okay, so is 10 over 8 equal to 18 over 14.4? So if that is true, by the means extremes property, 8 times 18 should equal 10 times 14.4. Well, this is 144. Let's see, that's going to be 64. 8, 14. Yes. Okay, so both of those are equal, so that implies that those sides are proportional. So that implies, yes, these triangles are similar. And I can write my similarity statement right here. Triangle ABC is similar to triangle DEF. Okay, now another note here. Don't necessarily go alphabetical order on both sides, because these could be, these letters, if they're switched around, like I put D here and E here, I have to put these in a different order. So the angles that are the same have to go together. B has to go with E, so they're both second. A has to go with D, they're both first. C has to go with F, they're both third. Okay, is it possible to find X, Y, and Z? Okay, if it is, find them. So let's start with the angles. I always like to start with the angles because they're usually the easiest. Let's see here. So, okay, these are 90-degree angles, which implies these are parallel, by the way. And that makes this angle and this angle corresponding angles, so they have to be equal. So this is 32 degrees. Okay, I can use... now I've got a small triangle right here, and I've got a big triangle right here. Sometimes it's helpful to separate those. Okay, and it takes a little bit of work, but you know, whatever helps you get it right, right? So I could do this. I could take this triangle, put it here, and that's a 4. That's a Z, that's a 32, and that's a 90. Okay, and then I've got this other triangle. I'm telling you, this is a bit of extra work, but it's very helpful. Okay, now this side is 9. This is 90. This is 32. And this side right here, here's where a lot of people make mistakes. This side right here is 6. Okay. Now, I know that these two are equal to those two, so that makes this by angle. Those triangles are similar. Okay, I can easily figure out what the other angle is, because 180 minus 90 minus 32 is 58. So this is 58 degrees right here. That's the same angle, by the way, because they're both up here. So I found Z easy enough. I found Y easy enough. Now to find X, that's not hard, because here's X right here. Well, 4 is to 6. As X is to 9. So this is just 2/3. You can look at this one and get this one right. 2/3 of 9 is going to be 6. So you could also do it this way. 2 times 9 is 18, divided by 3 is 6. So that's 6 right there. And I've solved that triangle. I know all the angles. I know all the sides that I can figure out. I don't know... I mean, I suppose I could use the Pythagorean theorem and figure out this side and figure out this side. But, yeah. I think it's helpful to take the picture apart, especially if you get stuck. I mean, if you can handle it doing it the other way, great. Have at it. It's a lot less work. But if you're getting stuck, just redraw the triangles separated from each other, and put in all the information where it goes, and then it usually makes it a lot easier. Okay, are these two triangles similar? If so, find x and y. All right, so I got a 38-degree angle and a 38-degree angle. I don't have any other angles, so I can figure out this one. Let's see, 180 minus these two are together 108, so that would make 72. This is a 72-degree angle. But the problem is I don't know this one, so I can't figure out that one. So I'm going to look to the sides here and figure out, okay, are these sides proportional? So the smallest side, wow, I don't even know. Let's see, this is going to be the smallest side because it's across from the smallest angle, so that's 16. And the smallest side would be across from the smallest angle, that would be x. Okay, and then I've got the largest of the 70-degree. Yeah, I can't even tell which side is going to be the longest side. On this one, this is all messed up because the longest side should be across from the longest angle, and it's not. So these triangles, these are all jacked up. No, these are not similar. In fact, this can't even work. This can't even be a triangle because the smallest side is not across from the smallest angle, so that's not going to work at all. Okay, what do we got here? All right, we got this situation. Find x, y, and z. Now, this is a complicated picture that people have a very hard time with. There are actually 3 triangles that are all similar here, okay? All of them have, okay, so you got the big triangle, you've got the small triangle, and you've got the medium-sized triangle. All of them have a 90-degree angle because if this is 90, that has to be 90. Okay? This one, the small one, and the large triangle share this angle, so by angle, they are similar. The medium triangle and the large triangle share this triangle or this angle, so they're similar by angle, which means all 3 of them are similar by angle. Okay, so what should I do here? This is definitely a case where you might want to take these and take them apart. I know you can't do this on your paper, but you can redraw these. Okay, so this one, x would be this side right here. This would be h. This is a 90-degree angle. This would be 24 centimeters. Okay. Then I've got a medium triangle. That's this one. Take that. I like to rotate them around so that the similar sides go together. Okay. So this would be h. This is this side right here. This is my 90-degree angle. This is y. This is 40. Okay, and then I've got my big triangle. Is that one right there. Now that one's backwards, so I'm going to take this, and I'm just going to flip it like that. Okay, and then this is 24 centimeters. This is 40 centimeters. And this is 47. Okay. This is 90. All right. Find x, y, and h. Okay, so I need to find 2 things. I know the hypotenuse of each one of these. Okay. So I could start with... and I know all 3 sides of this one. So I'm going to use this as my triangle that I'm going to measure everything else off of. So 47 is to 24 as 24 is to x. So I just need to solve this problem, and I found x. Okay. So x is going to equal 24 times 24 divided by 47. That comes out to 12 point, approximately 12.26 centimeters. Okay. Now, since I made that approximately, I am not going to use that to find anything else unless I have to. Okay. Now let's find h over here. So I could use the Pythagorean theorem here, but this is not exact. It's approximate, so I don't want to do that because that introduces error for h. So here, 47 is to 40. So this is to this, as 40 is to y. Okay, so y is going to be 40 times 40 divided by 47. So that's 1600 divided by 47. That's about 30.04. 34.04. Centimeters. Okay, so that was y. Yeah, that was y. All right. Now I need to find h. Okay, so I can do that with either one of these triangles. So again, I'm going to use, let's see, 47 is to 40 as 24 is to h. 47 is to 40 is 24 is to h. Okay, so that means that h will be 40 times 24 divided by 47. That's about 20.43. Now that's going to be the same here as it is here. Okay, there's a lot of work in these. It's best if you tear them apart. If you tear the triangles apart. Okay, now what you could do, I would throw these into the Pythagorean theorem to check and see. You know, you're not going to get exact because these are decimal. These are not exactly the right answers, but you're going to get really close to 40 if that's right. So I would check that in the Pythagorean theorem and see if you got that correctly. Okay, so here's a little assignment for you to do. Have fun with that. I'll see you guys later.